Hi and welcome to another lesson in the physics video series. Today we're going to find the easy way to graphically determine the vector resultant using the parallelogram method. Alright, let's get started. There are three basic vectors that you're going to be dealing with in a physics curriculum. A displacement vector, which is a distance in a certain direction, a velocity vector, which is a speed in a certain direction, and a force vector, which is a push or a pull in a certain direction. Now there are other kinds of vectors, but they all fall into the same set of rules when trying to find the resultants. So when looking at vectors, there's only three ways that a vector can be connected to another vector, and let's take a look at them. When you first meet two vectors that are connected, you have to check to see if they are connected head to head, meaning that the arrowheads are touching, or tail to tail, meaning that the tails of the vectors are touching, or head to tail, meaning that the arrowhead of the first vector is touching the tail of the second vector. The head to tail connection is the way we want to determine the resultant. So if the vectors are connected in either head to head or tail to tail, one of them must be moved to get it into the head to tail configuration. So let's take a look at how that works. I have here in front of you two types of connections, either head to head or tail to tail. Both of these are not the correct configuration for a directly drawn resultant line. So what you have to do is a three-step process. Step one, you're going to pick a vector to translate. It doesn't matter which vector you pick. If you have two vectors, pick one of them and move it so that it now connects head to tail. So this dashed line that you see right here is the shadow of where vector 1 used to be. And then I translated it. I slid it over parallel to itself. You cannot change the length and you cannot change the angle. But once you slide it, you take this arrowhead and you connect the head to the tail. So in the case of two vectors connected head to head, I take one of the vectors, in this case I picked vector 1, and I translated it. You see the shadow. This is where it used to be, and now this is where it is. So now they're connected head to tail. In the other configuration, when two vectors started out as tail to tail, I still picked one of the vectors. In this case I picked vector 2, and I translated it. So it used to be where the shadow is, and I moved it all the way to the end of vector 1. So step 1 is to pick a vector to translate. Step 2 is to slide the vector to the tail of the other vector. Step 3 is to connect the tail of the first vector to the head of the second. That's what you see here. Tail of the first to the head of the second. And again, tail of the first to the head of the second. What if you didn't pick vector 1 to translate? Well, that's okay. You could have picked vector 2 to translate. So here in this bottom set of pictures, you can see that I have the full parallelogram. I could have picked vector 1 and translated it, and there's its shadow. Or I could have picked vector 2 and translated it, and there's its shadow. Either way, you have the diagonal of a parallelogram, and that's why this is called the parallelogram method. Let's look on the other side. I could have taken vector 1, which was here, and translated it, and there's its shadow. Or I could have taken vector 2 and translated it, and there's its shadow. Either way, you have to get the vectors in the orientation of head to tail in order to determine the resultant. Because once they're in the head to tail configuration, then it's very easy. You draw a resultant from the tail of the first to the head of the last. So if you have two vectors, or three vectors, or 100 vectors, it's the same process. Tail of the first to the head of the last. So the most important thing is to see how are the vectors connected when you first start the problem. Either they're head to head, which is inconvenient and needs to be changed, or tail to tail, which is also inconvenient and needs to be changed, or head to tail, which is convenient and in the proper configuration. Only vectors that are connected head to tail allow you to draw a direct resultant. Otherwise, if they're head to head or tail to tail, you must translate one of the vectors and connect the tail of the first to the head of the last. And remember, that looks like this. Tail of the first to the head of the last. And that's the parallelogram method. I hope you enjoyed this video, and thank you for watching. We'll see you in the next video.